John Hosking aho, ko ao te manukura pataio. Welcome to you all. I'm John Hosking. I'm the Dean of Science at the University of Auckland. It's my pleasure to welcome you to the first of the 2020 Gibbons Lectures. These lectures were established in memory of Peter Gibbons, who was an influential leader in the Computer Science Department, now Computer Science School, and had considerable influence over the shape of the department and its curriculum. Many of us owe a great deal to Peter for his mentoring. This year, the theme of the lectures is AI and society. Artificial intelligence, or AI, promises to make improvements to our lives in so many ways, including enhancing efficiencies in the workplace, generating productivity gains, and having a positive impact on our well-being. While AI promises to have a far-reaching beneficial impact on our society, it evokes not only excitement but also fear. There are fears around privacy, trust, freedom of speech, and the usage of AI and its regulation. The 2020 Gibbons Memorial Lecture Series will discuss the fears and excitements of AI today and in the future, and the impacts it could have both on us and in our society. This first lecture is entitled Our Future with AI, and will be delivered by Professor Michael Witbrock from our School of Computer Science. Michael decided at the age of about 12 he was going to solve AI, waited out his time at Otago Boys, and went on to Otago University to make a serious start on the problem by studying computer science. He graduated instead with a degree in physiological psychology before heading from the dismal climate of Dunedin to the even worse climate of Pittsburgh, where he did his PhD. Then had a misspent early middle-aged working on information retrieval and symbolic AI, and a couple of startups, ending up with a return to neural networks mixed with symbolic AI at IBM Research. Fortunately, we lured him back here to set up the Broad AI Lab, where he works at the intersection of machine reasoning, low-data deep learning, and natural language understanding, with the aim of AI that is far more broadly applicable. Michael, can I invite you to the podium?
Thank you. Right, so I'm going to speak reasonably quickly. May not be quick enough to actually get through everything, but we'll see how we do. So AI is about thinking, fundamentally, and it has very deep roots. It has roots going back to 4th century BCE, where Aristotle sat down and thought, what's this thing that we call thinking, and how might we understand it? How might we understand it at an abstract level? How can we take it and make it and understand it and make it more reliable? Another thing, of course, that AI is about is the thing that brains do, right? So knowing with any depth what brains do, or even knowing with any certainty that that's where thought happened, is relatively recent compared to sort of thinking abstractly about thought itself, which is weird. This concrete thing, the brain which does thought, was understood far less than the sort of abstract thing that thought is, but that's kind of how humans are sometimes. So this guy, Santiago Ramon y Cajal, taking advantage of the development of microscopes, made some of the first anatomically informative drawings of neuroanatomy. And you'll see that these two sort of threads, the philosophical kind of symbolic thread, abstraction of thought, and the thread of understanding what the brain does and doing something with that, are sort of coming together in a big way at the moment. So we talked a little bit about the past. We're going to dig into the past a little bit more in a different way and think about, well, how have human beings thought? Because the way we've thought has changed over time. It has different aspects, but also it hasn't remained the same kind of at all. So one way of thinking about thought and human thought is that we have two ways of doing it. One is like really very much like what animals do, and one is not. With very small exceptions involving keas and occasional actions by dogs, which are not reliable at all. Oh, and chimpanzees, which really aren't animals at all. They're kind of people. All right, so there's two types of thought. There's something called, so this is from a book, Thinking Fast and Slow, and there are sort of two systems of thought. One is quick thought, which is done well by animals and people on massively parallel algorithms implemented on massively parallel computers like a brain, right? And it was done poorly until recently by computers, and this sort of thinking is not impressive at all to ordinary people. It's the thinking I do when I say that's a camera and that's a beard and that's an Apple symbol and that's John Hopkins, right? Automatic, don't have to worry about it. It's not hard, but it's like really complicated. So it's now achieved on computers kind of by virtue of making the computers simulate brains, right? Which is like really inefficient thing to do. But we're getting pretty good at it. The second type of thinking is the sort of thinking that made humans win, for better or worse, right? Human beings are the dominant species on this planet, rapidly consuming it. And it's because we can do this thing called sort of symbolic thought, abstract thought. We can sit down and think about a problem, we can break the problem down into sub-problems, we can nut away at them, we can give them to other people, and we can sort of assemble answers out of them. That's kind of a superpower. It's serial and slow, it's hard, we don't like doing it. It took me so long to write this talk because we don't like doing it so much that we'll do almost anything else, and it's done poorly by most people. In fact, it's done poorly by all of us, I would say, as we will find out in the fairly near future. And when it's done well at all, it's impressive. We give people prizes, we give people professorships and the like, right? If they're at all good at it, even though they're probably lousy at it objectively, relative to the other people, they're good at it, so we give them all sorts of prizes. Right, and that sort of thought was the fundamental design principle behind computers. All right, so that's nice, but that's not what I'm most concerned about at the moment. I'm sort of more concerned about how our thinking, how the way that we think has changed over time. So, if you think about us, say tens of thousands of years ago, right? We did what was now called learning from biggish data. Right, we have a bunch of observations. Those observations correlated with other things in our environment. Sometimes they come with reward signals, and we do that over and over again. So, we suck on the straw and get an ant. Well, so that's the other kind of people, but close enough. And it's really slow and difficult to reuse, right? It's done again for every human being. Right? For every animal that learns this way, they have to do it again and again and again. When one dies, you make another one, they have to do this again. It's just so tedious, right? So the benefits of this sort of learning cannot be shared at all, because this is like 100,000 years ago or so before we sort of upgraded our thinking, right? And the only way you can share the benefits is I go and kill a wildebeest or something, and because of the stuff that I learned, and you guys get to feast, right? So indirect sharing of benefit. But then we came up with talking, right? Good for us, right? We're already ahead of the other types of people, right? So we came up with talking, and we came up with abstraction, and both of those are sort of really good. Talking means that we can transmit. Well, you need abstraction to do talking at all, but once you've got the abstraction, it's useful in its own right. So we can use concepts generally. We can apply them to new situations. We can give those concepts to other people and say, animals generally, if you knock them over the head with a bone, right, they will die and you can eat them. Right, and no more taking the kids on hunts to show them this. We can just give them that, tell them to go off and do it, and everything will turn out really well. Right, so this means that you can now not only share information with yourself, not only just share it one-to-one, but you can share it with small groups. There's exponential spread of information, potentially, although we didn't get good at that until recently. And it allows little things like agriculture, navigation, things which allowed us to start our attack on the planet. Right, the bad thing about this is that when you're dead, and you can't do this anymore. And until, this is a map from 1800, and that's all the places where you probably didn't get to live beyond 40, right? Back in 1920, 100 years ago, things were looking up, and there were a few places including, well, actually there wasn't data for New Zealand, but including Australia, where you might reasonably live to, the ripe old age of 60, 65. It wasn't anywhere where you're going to live anything like the ridiculous spans that we now enjoy. Right, so you did. You've acquired all this knowledge, you've generated it, but when you're dead, and that knowledge might persist if the oral chain is maintained, but much of it won't. So we've lost much of our history because of this oral transmission. Right, so then we invented knowledge permanence. We invented writing. That's really good. The knowledge can be accessed at any time. It can remain unchanged over generations, unless, like the scroll from Herculaneum, you end up in a volcano, and it can accumulate to an unlimited degree over generations in buildings, not unlike this one. Although this form of accumulation, I think, is on the same path as those forms of accumulation. Don't tell it to the librarians. I like libraries. They're like really nice environments. Oh, and that scroll there, even though it was burned in a volcano, we now, because we are cleverer than monkeys, are able to read it without opening it at all. So it turned out it was much more permanent than you would have thought at the point that when it was created. All right, so that's really good. We can now store this knowledge permanently, but it's like in libraries and stuff. And if you want to put two pieces of it together, it's hard, and you need to get someone who understands both the pieces, and you have to do that thinking stuff, and that's hard and unpleasant, right? So it's still hard to apply this knowledge that you've accumulated to new situations. And how are we doing? Fine, right? So now we developed ways of formalizing thought, right? So inference, right? So now we're getting beyond how perhaps most people think about thinking, but that's okay, right? So starting with Aristotle, actually, starting before Aristotle, obviously, starting even in the oral times, I think people were probably working on formalizing thoughts, but we really got going on this, starting with the ancient philosophers in Greece and China and the Middle East and probably South America. And what does that give you? It means that you have reliable methods for, so this is things like the scientific method, it's things like logic, it's things like formalized legal thought, it's even things like formalized theologies, formalized metaphysics with respect to some belief system, right? So it's like ways of making thought of various kinds more reliable. And once you can do this, you can know when you're trying to solve a particular problem, how you might go about doing that with some guarantee that you'll get a solution. You know that go to this place in the library and go to this place in the library and bring together information of this type and look up this thing, and then apply this rule of inference or collect this much data, and you're able to make a conclusion. So this was really good, and it gave us philosophy and mathematics, and it gave us science, and it gave us the techniques which allowed Rosalind Franklin and others to understand the fundamental basis of our biology, for example, by decoding DNA, right? And this is sort of ramped up. That there is a lovely thing. It's the first scientific, actually it's the second scientific journal ever, but only by 3 months. So I'll give it give it a prize anyway. Right, and then what did we do next? We came up with ways of, so we've taken sort of like facts about the world, these concrete observations, these things that other animals can do to learn from. We've abstracted them, but now we can broadcast those abstractions. So instead of going to a small group and relying on that, instead of it being stored in libraries, we've made increasingly sophisticated ways of sending this knowledge to many of us or all of us. So printing, first broadcast medium really, radio, TV, the web, Facebook, YouTube, TikTok, Neuralink, but not quite yet. Right. So the upside, the upside of this is that potentially you can get all of the knowledge all of the time. You don't have to go to a building like this. So all you've got, the problem is still just assembling the knowledge. It's no longer obtaining the right knowledge. But the downside of this is that there's too much. There's way too much. There's way too much, right? So which means that the problem is that we humans are not up to thinking with that kind of input, right? So this technology of broadcast has overwhelmed our capacity to think. And now we have to do something else about it. And what are we going to do about it? Well, we're not quite there yet, but a start on doing something about it is that not only can you broadcast cat videos, right, but you can broadcast data. You can send in fact, when the web was invented, the idea originally was that one of the main protocols was one for sharing data. Do you know what that is? Is that a fire alarm? All right. That you could share the data at scale, right, and that computers could access that data and perhaps use it or perhaps process it, right? So we are here, right, in the development of AI. Right, so taking headphones off stops it. I've learned that abstraction. I will try and apply it in future. Right, so we are here in the history of AI, where we've got really access to data. We've got good techniques for using data automatically. We haven't got good techniques for deciding how to use data automatically. So not only are you here, but this was 1986, so I was there. So this was a nice sort of memory. And I don't know, the internet already seemed a little bit more complicated than that. There were even tiny little bits of it in New Zealand in 1985, something called PACnet. For those of us who are ancient and therefore nostalgic. All right, so we're now at the point where we can take that data, we can feed it into computers, and they can do abstraction for us. That's called machine learning. But again, it's kind of overwhelming, and we're not all that good at it. And people complain when we're not good at it because we end up, I don't know, making bad decisions, right? So what can we do about that? So, so we get data bias, we get modeling error, we get all sorts of bad things. So what's the way forward from this, right? The way forward from this is clearly artificial intelligence, where we automate the whole damn process, right? We're running into all these things where, like, human beings are not up to the task of doing the learning from data. We're not up to this task of processing and filtering the data that comes into us from these broadcast media. We're not up to the task of dealing with the speed at which we can transmit data around the world. We just can't do it, right? But we still want to think, and we want to get better at thinking. So data collection, augmentation to knowledge, data adaptation, inference, checking, explanation, and ultimately development of new AI techniques. Why don't we just hand that over to machines and free the humans to do whatever the humans want to do, right? And what I want to do is not most of those tasks, right? Now the downside of that. So the good thing is human beings get to be children and play with bubbles, right? Or whatever we want to do. The bad thing is, maybe maybe this will have some unintended societal impacts which will make algorithmic bias, as people call it, seem like a walk in the park, right? So that wouldn't be good. All right. So suppose we're going to do this AI stuff, right? We've been sort of heading at that for a while now. In one form, we've been heading at it since 2,500 years ago or so, when Aristotle sat down and formalized some stuff, right? In another sense, we kind of started getting serious about AI and like inventing the name around 1950. 1940s, 1950. So we invented an algorithm for machine learning, neurally inspired in the late 1940s, for example. We developed the Turing test in the 1950s. This room beeps far too much. Not enough AI. Right, so we sort of started getting serious about this, including inventing the name AI, which we kind of later in the 1990s or so decided was a bad idea, and now we've come back to using it again because it's a good idea, right? So, all these are sort of AI systems in slow, steady progress, but it wasn't like the big thing it is now. All of those are worth looking at. So at the time we were making that slow progress, there was an old definition of AI, which is essentially everything we don't know how to program yet, right? That was kind of the joke idea about AI, but I don't think we believe that anymore, right? Because AI systems are doing all sorts of things, and we still don't know how to program them, right? So there's a kind of new definition of AI, which is everything that we can train a system to do, and probably won't end up understanding. I mean, we have no idea how Alpha 0 really works, right? I mean, we're chipping away at that, right? But we probably will never fully understand how those systems work in the same way. Well, we won't, right? We humans won't. Human civilization, you betcha, we're going to understand that, right? So we're now in this place where we're doing machine learning for everything, and it's going really well, right? The idea in machine learning, or at least the kind of AI-flavored machine learning, is that meaning is implicit in the data, right? And you pour enough data in, and you boil it down using a fancy algorithm into a fancy heuristic. And everything will work, and that thought is just the transformation of learned representations into other learned representations. And that's going pretty well, right? So this is for 5 years ago now, an attempt to generate some Shakespeare with a language model, pretty good. Made Andrei Karpathy pretty famous, and he's gone on to bigger and brighter things, and he also gave us a method for sorting through the papers in archives. So he has contributed much to humanity, but that wasn't enough. So this is like a couple of years ago, there was something called GPT-2, which again thinks that meaning is implicit in the data, and you throw it into a big enough algorithm which will abstract representations, and it will be doing thinking. So this is GPT-2 generating Shakespeare, and Shakespeare generating Shakespeare, and your task is to work out, is that Shakespeare, or is that Shakespeare, or is that GPT-2, or is that GPT-2? All right, so think about that for a little while, and I'll give you the answer at the end. Oh, by the way, that's GPT-2, and GPT-2 is dumb as bricks compared to GPT-3, which can not only spill out fake Shakespeare, but it can actually solve some sort of simple problems just by writing the problems down. And this is all by just abstracting down a whole lot of text, right? I mean, you would not believe how many texts, and applying, gosh, I haven't done that calculation. It's many bees worth and a substantial fraction of a mouse worth of neurons, of artificial neurons to this. So this is GPT-3 is about 600 billion weights So not neurons, but weights. So getting pretty. So and then we're totally winning, right? So GPT-3 can really solve some real problems. It can spit out text which will fool you. Can write an article in the Guardian, maybe with some strong Guardian, Daily Telegraph. I don't know, somewhere with some strong editorial control. So we're doing pretty well. And we are doing pretty well. We can win at Jeopardy. We can have debates with computers. We can generate text. We can do significant amount of work predicting how proteins will fold. We can, using learning, get control over the plasma in fusion reactors. Right, so this stuff is working out really pretty well for us. And around 2050, the single largest computer at the current rate of improvement, and this has been true for since I first did this calculation about 10 years ago now, and it still remained true. Other people have been doing it for longer. So around 2050, one computer will have approximately the same aggregate computational power as all of the humans, even accounting for us continuing to exponentially increase in number. Right, so that suggests that something's coming, right? So, but maybe we're not winning as much as we seem to be winning, because this stuff's all really very impressive. But all of the knowledge in these systems in GPT-3 is stored in opaque parameters, so we don't really know how to reuse it. And more to the point, it doesn't really know how to reuse it, right? There's a lack of transfer to new problems. We tend to have these systems trained up for a particular task, even if it's a task as large as generate the rest of this passage, right? And they don't really transfer to other things very well at all. It's only by making the task, we can kind of cheat by making the task large enough. In the case of GPT, it's like, we produce all of human language that's stored on the internet. In the case of AlphaZero, it's like play any game, right? But it's just a large task, and we can't generate explanations for it, which is another way of saying that these systems don't really understand the knowledge that they have, right? So maybe we're not winning. And remember, it's this state of affairs that we've scaled up in AI was the beginning state of affairs for human thought evolution, right? So I don't expect us to take 100,000 years to upgrade our AI's thought. I expect this to happen quite rapidly, but it's only just started. So what do we need to do with AI to get to human level knowledge use, right? To be able to do this stuff, right? That our boy Ernie there did, right? Because that would be like really super useful. And this thinking stuff's hard, and no one really wants to do it, right? So it'd be just easier if we can get it. So how are we going to do that, right? Well, by combining something like reasoning, something like inference, this hard thing which is super useful when we do it, with this learning that we've got really quite remarkably good at recently. Not good enough, but quite good, right? Means that we need to have computers be able to manipulate, as we can, right, symbolic abstractions, right? They need to be able to take their knowledge, they need to be able to put a label on it, and they need to know when they're reusing it, and they need to be able to work out general ways of using it. And the experiments we've done so far in our lab here suggest that these systems, these transformer-based systems, find it extremely difficult to perform these inference operations. Right? It's not that it's impossible, it's just that they haven't needed to. They can cheat on the test and fool us humans, so why bother learning to do these operations? But these symbolic representations are everywhere in the systems that we depend on. Right? So all the way from so some symbolic knowledge, which is text-like, ranges from mathematical logic through to poetry and song. You might not think of those as the same sorts of things, but they really are, because they're just levels of precision versus levels of coverage. right? Mathematical logic, for sure you're going to get an answer, but you can get an answer about almost nothing. Poetry and song, you can talk about anything, but it's like sort of difficult to know sometimes what you should take from it. And the things in the middle kind of likewise to different degrees. And it's not just text, right? The same stuff is true that there are symbols approach, symbolic knowledge contained in pictures, and this is becoming actually clearer now because there are systems beginning to be developed which jointly treat images and text together, right? And you can actually begin to see some of the symbols in the images that these systems use, right? So, so the last thing I'm going to run through very quickly before I talk about our future with this stuff is what it actually means to do inference. So we're going to take these deep learning type techniques, these transformers and so forth, and whatever we develop next, and we're going to apply them to the problem of reasoning. So what's reasoning? Reasoning is just taking a problem, like, is Honolulu a city, right? And breaking it down into problems that we are nearer to being able to solve. It's like, is Honolulu a city? Gosh, I don't know. Maybe if I worked out if it's the capital of a country, right? Because I know that when something's the capital of the country, it's almost invariably a city. I don't know how you count Canberra, but there it is. Right, so is Honolulu a capital of a country? Because if it was, I know it's a city. Well, it's no longer, sadly, the capital of a country. It was the capital of a country between 1845 and 1893. So if we'd asked this question back then, we would have been able to say yes here, but no, we've failed on this path. Right? It's not that we know it's not a city, it's just that we can't prove that it is, right? So that way of solving the problem has failed for us, and we need to try something else. So my view, possibly because I grew up in Dunedin, is that it's a city if it has more than 70,000 inhabitants, which even back then it, just managed, right? So so if X is the number of inhabitants of Honolulu and X is greater than 70,000, then it's a city, using the Dunedin rule, right? And it's in fact 351,800 inhabitants, so pretty big. And that number is greater than 70,000. Using our splendid mathematical prowess, we can show that. That is an operation that's so much easier for computers than for us. You would not believe how easy that is for computers. If it takes more than a nanosecond, you're slacking, right? So it's a city because it's 70,000, and yes. So what have we done? We have broken down the problem into smaller problems. We've looked up the answers to those smaller problems. We've eventually got problems where we know the answers to them, and then we use them to assemble the answer. And that's all we do, really, which makes us more powerful than the other animals, right? And if we want this AI stuff to happen, that's what we have to teach computers to do very generally. Right, so to go back to our question, the answer is that that one's Shakespeare. I hope, because it's difficult to, it's a little bit difficult to tell, but I looked it up, and last time I checked that was true, and that is GPT-2. Right, and don't read Shakespeare or GPT-2's things because maybe it'll annoy you. Not my favourite Shakespearean play. All right, so we've got this lab here at the University of Auckland called the Broad AI Lab, where we are trying to solve AI and save humanity. No, that's Deep Mind's slogan, so it can't be ours. We're trying to teach computers how to think. And we're doing that by combining deep learning, knowledge acquisition, and automatic reasoning together, and we're to make broadly capable AI systems which can do the sort of things that a human being can do when you plonk them down in front of some text or some data or a keyboard, right? And because this AI stuff is probably going to work, one way or another, somewhere, we would very much like to contribute to making it work so that we can drive that towards positive outcomes for the humans and all the rest of us. Okay, so we are now in 2020. Who knew that we would get to this point? Somewhere out there, C-Lab is doing its stuff, and people are swimming around with aqualungs. Sorry, these are ancient pop culture references, but fortunately I have a fairly ancient audience like myself. Right, so we're now in 2020, unexpectedly. We survived this long, and we would possibly like to survive a lot longer. What's going to happen over the next few years? And what should we do about it, right? So that's AI in the future that we've finally got to. We've still got some time, so that's good. So as I said, this AI stuff is probably going to work, right? And computers, one computer is going to be somehow computationally more powerful than the whole bunch of us humans, sometime around 2050. So, that's no guarantee of general artificial intelligence capability, but it sure removes a lot of barriers from it, right? There's no longer any excuse for not making this thing think if it's got more brain than all of us put together, right? So somewhere between now and 2100, and probably well before 2100, we are going to go through inter alia this sort of evolution. We're going to get systems which can do large-scale reasoning. At some point, human mathematicians will go kind of out of business in the same way that human chess and Go players are now out of business, which is not really at all, right? In fact, there's a resurgence in chess and Go interest, but what it means to play chess has completely changed. And I guess one thing I'll get to is what it means to have a job will completely change in that way, and we need to work out what to do about it. So we'll have general assistance, right? Things which, all this stuff that comes in my email telling me to do stuff that doesn't matter. Something will just take care of it. Yes, some of it from you, or not from you directly. Right? We'll have better than human speech synthesis and recognition. I think we're near that point now. I did my PhD in speech recognition, and in trying to understand speaker variation. And our systems, you would not believe how good our systems now are. In fact, sometimes you watch YouTube videos and the thing speaking is a computer, and the way you can tell that the thing speaking is a computer is that a human being wrote the text, right? And that human being did not speak English properly, but the computer speaks it perfectly, and it's very strange, right? So speech synthesis we're really good at. Very soon it will be the case that your phone will be able to pick up you mumbling at it in ways that none of the human beings around you understand, probably, if for no other reason than it can have more microphones around if it needs to. We'll have general conversational interaction, no more saying, hey, okay, Google. Fortunately, I disabled my phone, or hey, Siri, or Alexa, something, whatever.
Your phone's in flight mode, so I can't help you with that at the moment.
Right, so no more of that, right? We'll have better than human translation, probably. And in some sense, we already do, because of, Google Translate knows a whole lot of language, and it's really good with the technical stuff. It's really lousy with Maori, but it's good with languages where there's a lot of text out there. We'll have broadly capable robotics, right? That's coming because sensing is almost a solved problem, right? So object recognition, perception is kind of close to solved in the ways which have been real barriers for robotics, right? And now it's more, how do we make them act safely and reliably in the world? How do we acquire knowledge in order to make them more capable? And frankly, how do we get the economics to the point where we're in the fast takeoff mode? So around 2002, we were in fast takeoff mode for speech recognition, because speech recognition was ubiquitously deployed on iPhones and Android phones, right? That's going to happen with robots. We're going to get a few capable ones out there being used widely, and that will mean that we start getting really, really good at making robots, right? In the same way, we got really good at TVs, we got really good at phones, we're getting really, really good at batteries, we're going to get really good at robots, and that will just take off and happen, right? We'll get broadly capable corporate AI, where the corporations don't really need the people running them anymore. Right, that will happen, so think about that. And then we'll get general super intelligence, and this is going to happen, it might happen in our lifetimes, right? Especially if we get some of these things earlier in our lifetimes, get longer. Right, so that's great. This stuff's going to happen, but it might go badly. Yep. Elon Musk is worried about it, and he's not wrong to be worried about it, and the arguments he makes are reasonable arguments. So we need to do what we can to help AI not go badly, and I think that this country has a role to play in that. So there are some things that we need to avoid and mitigate, right? In particular, bad consequences from replacement of human work, bad consequences from replacement of human autonomy with automatic decision systems, bad consequences related to intellectual property and the accumulation of the sort of capital that these systems represent, bad consequences from the general inutility of humans, but not, we hope, their lack of value. These are things. These are things which could go wrong, and they could go wrong mildly, in like a lot of people becoming poorer, or they could go wrong really, really badly in ways that you can look on the internet to find out. All right. But things can also go really well for us, right? So, we can help AI to go well as help it not to go badly. We can attempt to use it to achieve or maximize health, longevity, and justice for people, equality of access to resources, especially the resources which are sort of generated by what should be the biggest boom that humanity has ever had. We should use it to maximize freedom of people and people groups, and of animals where possible, and of the environment to reach their full potentials. We should use it to increase, where we can, the ability for human beings to act autonomously and not be interfered with, and also to act within their communities. And we should use it to care for our land and our planet and our planets, which will probably happen too. And maximize the sustainability and reach of human civilization, right? So all these things, just as all those thought technologies that we had in the past enabled sort of increases of this sort and also kind of downsides, this is true here too. This can be hell or nirvana or anywhere in between. Right, so where do we, little New Zealand, fit into this? Well, some things that New Zealand is not terrible at. Rugby and rockets. Probably not directly relevant here, but pretty good at them. We are good at growing things, right? We're super good at growing things, so maybe we should think about applying AI to that. We are good at social progress. Not good enough, not nearly good enough, sadly. But if you look around the world and think, do we suck at this? No, we do not. Right? So, in fact, the University of Auckland got a prize. Yeah, yay! Yay, New Zealand, one of its your universities got a prize. And we did a whole lot of other, not as it turned out, bad things. Right? So this is something that we might think about, how to actually apply AI for social good, because there's a good chance, because of our history, people will listen to us. That's this one that we're not bad at. We're good at not being noticed, right? So we're not annoying. We're not even there half the time, right? But we're kind of noticed at the same time. So per head of population, we have a pretty big platform in the world, right? Stephen Colbert comes down here and talks about us to the entire world because of kind of who we are and what our history has been. So we can use that, and we should use that. So yeah, we can play a significant role in the path to a good AI-based future, partially because we've just got the other things which enable you to do this. We've got sort of educated, diverse, cosmopolitan sort of population. We are at the scale of a larger city, so we're at the scale where you can do something. We have the scale of large research universities, and we have some unique advantages, right? Our society has almost a unique, if imperfect, commitment to multiculturalism, right? In terms of developing international law or national laws to respect cultural diversity, New Zealand has contributed a lot. Again, we're by no means finished with this project, right? The glass is maybe only 90% empty, but it's 10% full, and that's not true in a lot of places, right? We have a desirable physical and social environment. People like to be here, right? So if we decide to do something, we can get people to do that with us. And that's sort of the same thing as the second one. We have high diversity, so if we have solutions here, we can test their applicability to a wide range of people and make sure that they're not doing particular groups more harm than they're good and just benefiting some. We have high social cohesion, which means that we can get away with doing stuff. Right? We can try stuff out, and people will kind of trust that it's okay. So we can do experiments here that can't necessarily be done in other places. So for example, just this morning, a National Party politician admitted to having got his sums wrong. Right? It's a fair cop. As an American as well, I cannot imagine, right? I just can't imagine that happening, right? That's a normal thing to do because we kind of trust each other not to overreact, right? That's good. We have one of the highest ease of doing businesses, so when it comes to actually deploying this stuff, we've got a good path for it, and we have very low corruption, so probably whatever we do, someone's not going to steal it and use it for evil, right? Not many Dr. Evils here. Right, and we got a prize. All right. So one thing that these are just kind of ideas of things that we might work on. So labor adaptation. So the end point is replacing the idea of human utility with human value, right? That's what I would like to see in the world. How do we enable human thriving if AI systems and robotic systems can do everything useful, which will happen, right? So this idea that new jobs will just come along, well, yeah, maybe, but they're not going to be anything like the old jobs where you do something useful for someone, right? That boat is going to sail reasonably soon, right? So, maybe we pick human roles like caring for others, crafting, art, culture, performance, skilled service, or cuisine to specialize in, and we do them as sort of performance hobbies, right? For social relationship building, right? That might be the thing that we evolve towards. I don't know. We can start thinking about that. We are almost uniquely placed to start thinking about that. Or maybe our role is taking responsibility for our environment. The computers are still going to actually do the work, right? But we can be the ones whose job it is to appreciate that kauri tree, right? That can be our job. Providing for, and we can work out how, maybe we can start doing the economic work of working out how you provide for all the people when you have gradual and uneven replacement of the job role. And there's reasons for hope, right? We're one of the places which develop well-being economics, for example. So we're going down this path, and also we tend to be kind of understaffed. So it's good if you're going to experiment with replacing human labor if you don't have enough of it, right? There are some opportunities here. We could work on AI for social services, right? So suppose the nanny state was always good kind, and non-intrusive, right? Would people object to it? Would it be bad? Well, certainly some people will still object to it, right? And because it's such a nice phrase, isn't it? It's so evocative, right? So there's a lot of worry now about algorithmic bias, but that algorithmic bias is not algorithmic, and it's data bias, right? And it comes essentially from people not doing the job as well as they might, right? And this problem will not persist in this form with broader AI, because the checks that you can do to make sure that you're not doing that bias, right? The symbolic checks you can do, and which humans do when they identify and mitigate this bias, they'll be able to be automated, right? So there may be some other unintended consequences, but they won't be those ones. So there's an opportunity here to work towards AI systems which actually watch these systems, societal systems, and make sure for every single person that they're not treated unfairly, that their hopes are not squandered, right? That they are not deprived of resources because of who they are. We could, for example, have a system which is inside classrooms just quietly watching and making sure that the teacher is going evenly around and talking to boys and girls, right? That doesn't happen at the moment. It could happen. Do you want a machine watching that? Well, I don't know, right? It really depends on how safe that is for the teachers and for the kids. The teachers don't want to discriminate. The kids don't want to be discriminated against. Their parents don't want them to be discriminated against. Maybe some of their parents want them to be discriminated in favour of. I'm not sure. But we're going to be able to build things like that. What should we do with them? That's a question. And New Zealand might be a place to kind of experiment with that. We probably should work on AI and robotics for health, because we're so small. We often have few specialists, which means we have queues for no particularly good reason. We have labour shortages. We have good health infrastructure, right? We have good physical infrastructure. We have good data infrastructure. We have good infrastructure in terms of information maintained over time, because we've done all these longitudinal studies. We have genetic data going back more than 50 years, if we choose to use it, and we have high quality research. So maybe this is something we could concentrate on. Maybe we can solve health, because the upside with AI is, suppose we understood, we human civilization, not us puny humans, understood everything about biology and no one ever got sick. That sounds pretty great to me. Lastly, AI and robotics for agriculture and the environment. New Zealand has a very sophisticated agricultural sector, which is very quick to adopt innovation, and it's also got a recent agricultural infrastructure, which means we have very large farms conducted with very little labour, right? Which means that this is a place where you can apply automation in a minimally disruptive way. So I think we ought to be working on that, in part because the more visibility you have into agriculture and the more efficient you make it, the less environmental impact that it has, and the more economic return it has. So suppose that we could clear for every single plant individually by having a little robot which goes around and picks off any insect that's the wrong kind of insect which goes on it, and shoos the bees towards it, right? And weeds any weeds which are around it, so we don't have to use pesticides or insecticides anymore. That is certainly possible, right? Maybe we can do it. But so these are some ideas. You'll have different ones, but New Zealand is not generally leading in AI. I considered leaving this bad news slide out. So maybe we're short poppies. I don't know. Right, so we tend to do some things which are not maximising our impact. So in the companies, we tend to optimise and deploy tech which is deployed elsewhere. We have a lack of easy flow of skilled innovators into the country or between companies. We've got a lack of easy flow of skilled innovators between the universities and each other, let alone between universities and startups. And our startups tend to be small and low growth, right? This is not optimal. We could do better. And our universities compete with each other what the hell is, with that, right? So you get duplicated research, you get a near-term application focus, you get, did I say, actually competing with each other, which, no. Right, so what can we do to affect AI? So this on the side, generated with some considerable effort, is a list of the cities which are like next bigger than New Zealand. All right, so New Zealand is and on top of those are all the big ones that you've heard of, right? So New Zealand is not a particularly big city. We should act like that, and what shouldn't we be doing in this big city? Having neighbourhoods in this big city competing with each other for no good reason. We should be supporting each other. We should be lifting one another up. We should be acting with purpose and unity. So we need to take what's the most important thing we can do to actually have an impact on AI? Take a whole country approach, right? All of the people who are working on this, sitting down and kind of working out what can we do to better affect and more quickly. We need to make some choices about focus. Good news is we're good at talking. We won't agree. We won't entirely focus, but we need to make some choices of focus. I suggested some things, but don't do them. Right? All I want is us to think of some things where we might actually help. We should use our special powers, right? As New Zealand has some special powers. Use them. I talked about them before. And we should deliberately have a plan to scale up. And I'm not going to go through these in specific detail. I mostly go through these when I'm talking to, say, startup or business audiences. But there are some things that where we're below scale compared to places like San Francisco or Austin or London or Berlin, where we don't need, or Seoul or Tokyo, where we don't need to, or Guangzhou, right? places where we don't need to be below scale. We're just below scale because we haven't deliberately made ourselves be above scale. So that's why we're going to get AI. That's why I think New Zealand should help. That's how I think we might help. And a call, perhaps, for us to get down and get this done, because there are a few things which could be more important for both our future and for our place in it. Thank you very much. And now, and modern AI is pretty awesome, so I'm going to play you something, because the university prevents the slide from playing properly, but workaround. Right, so that's the best band ever. And this is an AI system using modern GPT-3-like techniques taking over. And if you listen carefully, it's no worse than you or me when we don't know the words. And it's much better at the music part. Yeah. All right, so I'm done.
Thank you, Michael. Thank you very much. Now you get to have your own back on me, because I'm now your assistant. I have your social media here, which I'm going to filter and present to you. So
excellent.
These are questions that have come up on Slido, and you'll be pleased to know that there are more questions than we have time available to actually ask them. So that's fantastic. And I have an unbiased system for selecting them. That's the upvotes that the people suggesting them have put on. Your task, of course, is to determine which of these are questions that are generated by an AI rather than a human.
I wonder if anyone did that. You can. There are APIs out there.
First question is, what do you want AI to do in the future? Surely more than humans are capable of. Otherwise, it isn't progressing the world's capability.
Well, I certainly want it to provide long-term solutions for protecting Earth. It's the place that we are from. And I think we kind of want to probably turn it into something like a museum, right? So that means working out how to get stuff off the planet. I would like to solve biology so that no one needs to ever get sick or die or any of that stuff unless they want to, right? That certainly seems to have been beyond humans. I think in, what do I really want to have? I suppose understand physics as well, and tell us whether we can get faster than light travel or we can't, and if not, I suppose tell us how we can download reliably and completely, so that it doesn't matter to us that it takes 1,000 years to get somewhere.
Thank you. Do you think AGI will come out of decentralised AI? Multiple models that query and share information between each other rather than a single model?
I'm going to get all kind of computer scientists. It doesn't. There's no difference, right? I mean, it's like deterministic versus non-deterministic finite state machines. It's always, it really doesn't matter what the implementation is. Do I think they'll come out of distributed computing? Probably. Unless we get much better at, say, stacked wafer-style computers, and we can just build the whole thing together, or we build quantum computers using diamond inclusions. Right? This is just it's a hardware question. What the implementation will be. Right? What matters is understanding how to learn the right things from the right data.
Okay, there's a lot of ongoing research on safe AI, such as Google Brain.
Yeah.
Is there similar research at Broad AI?
Not at the moment, but it's certainly something that's of interest. I mean, I think that idea ran through this talk, right? But it's unclear whether you can get a guarantee of safety. The people who work on AI safety have sort of interesting ideas and interesting philosophical arguments, but whether you can have a guarantee of safety while also a guarantee of utility is kind of unclear. I think it's certainly worth doing the investigation. I would like to have people here in New Zealand, in particular, thinking about what it means to be safe, right? Which is a really interesting question from the point of view of the multiple cultures that we have in New Zealand, right? So what you regard as safe is by no means determinate, right? Is it safe for, is it, all right, I'm not going to come up with corner cases for safety, but I don't think we even know what safe means, and certainly I want New Zealand to be a place where that's discussed, and maybe a place where that's discussed by people from all around the world.
So perhaps something relevant to that. There are claims that social media AI knows us better than we know ourselves, and is used to influence us to consume, vote in particular ways, and so on. Thoughts?
Well, it knows some things about us better than we know ourselves, but it's the sort of things that it knows are at the moment extremely shallow. So whatever it knows, it's just stored in some model parameters, so it can make predictions, but it doesn't actually know anything about the content of those predictions. It can't even understand the abstractions, and because it can't understand the abstractions, it can't, for example, assign those abstractions to the types of classes that we use to decide that something is or is not inside a protected class, and that therefore shouldn't be talked about in a particular way. So I'd say kind of soundly no, right? But they know us in a way which is different from the way we know ourselves, and which is sometimes extremely dangerous.
And one last question, given that we're over time. Well, AI sounds really interesting, but will there be work opportunities for new graduates where some tech fields require degrees and years of experience first?
Will certainly be work in the short term, right? There will be, especially if the program for scaling up AI in New Zealand happens, there ought to be enormous numbers of work opportunities for people who are working on the fundamentals of this field and the commercialization of the fundamentals of this field. So in the short term, I think the future's so bright. They should all go out and buy some sunglasses, right? But in the long term, the idea of will there be work for no, and we just have to find a way for that to be there won't be work, there won't be jobs, and we have to find a way for that to be a good thing, not a bad thing. And the purpose of the education, again, would have to change from training people to do stuff for other people or for other organizations to training them to be good at being a human being in some particular way. And I think that sounds like a far better role for universities for the future if we can get there.
Thank you, Michael, and thank you for your talk. Very glad we managed to lure you here, even if the weather here does occasionally play tricks and closes harbour bridges and the like, but we're very glad to have you, and we do have good coffee here, which is another desirable attribute. There
almost was a picture of coffee. Well, there was the champion barista, right? So, yeah, so we do have very good coffee.